There we go, now we're live. What do you see?
Ready.
Ready? Yes. How are we going to start this? Math wizardry? Yes. There are two ways of doing this. There's a long way and a short way. The long way would be to actually multiply that by itself. Then take whatever you get and get a common denominator with that one. And then add them together. And then, like, it's just going to be, and then you're going to, yeah, it'd be crazy.
Crazy.
Do you see? Look at this. If I go like this.
Oh my gosh.
Ooh, what do we have? We have something squared plus the same something that's not squared equals 6. Ooh, do you think we could factor this?
Maybe.
Let's get it equal to 0.
Probably.
And just to avoid confusion, does that look easily factorable?
Blank.
Don't let all the crap in the parentheses
Blank.
confuse you.
Oh. Okay.
Here, watch. This is gonna blow your mind. Ready?
Oh my gosh.
Why do you write on your finger?
We'll see. Maybe. I don't know if I can do this like that.
What the heck are you doing?
Ready for this?
Hey!
Oh, snap.
Does that look easy to factor?
Yeah.
Oh snap.
Yeah!
Painful.
I got this thing squared plus this thing squared
Finger squared.
minus 6 equals 0. Cool.
Finger squared plus finger minus.
So then I'll just go,
Finger x plus.
let's all have this thing and this thing go here. And then how do I multiply it as negative 6 and add to 1?
Negative 3 and 2.
Negative 3, no, that's positive 1, right? There's the x in the egg. What's the number?
what? Other way
It's
around.
positive 1, right? Multiply to negative 6, so positive 3 minus 2. So I just need to put these things right here. Oh, so what's this? See it?
Yes.
That was weird. That was whack.
Can you finish it now?
No.
Okay. Why not? What do you do after you factor something and you have it equal to 0?
You. My next.
I found it, it's right there.
Solves.
Alright, Kessler.
Well, what are we going to do with those?
You X equals negative.
Just like regular old factoring,
Yeah.
right? Multiply to negative 6, add to 1. So that's how I do it. What do we do with our factors? Come on, Ernesto. What do we do with these? No? Cancel them out. Oh no.
Drop out.
Okay, let's go over here. Solve for A. Go ahead. Solve for A. Serious.
Plus 3 minus 3.
Oh, what?
I mean negative 3.
A plus 3, A minus 2 equals 0. So what's A equal?
Negative 3.
How'd you know? Oh, you set that equal to 0.
0? Oh, one of us say that?
Oh,
Yes.
Yeah, we said that.
someone said that?
Yeah.
I don't think so.
She
Yeah.
said it.
We'll go to video replay. Oh, so what are we going to do with these?
You go paper pop?
Huh? It was you? Oh.
Yeah.
Oh.
You're going to set them equal to 0. Now can you solve?
Yes.
Good.
Maybe.
How about the rest of you? Hopefully you realize you either just subtract 3 or add 2, right? What do we do about the fraction? Subtract 3 from both sides, make negative 3. Add 2 to both sides. I guess I should show my work. So you get 2. Now what? Multiply by x plus 3, right? Get it off the bottom. multiply by x plus 3, multiply by x plus 3. You got it now? Can't tell by the silence if this is too easy on board or... Now it's easy.
Yeah.
And now it's easy. On your worksheet you're about to get, you'll have a very similar problem. You actually have a couple of them. But on one of them, when you get to here, it's a quadratic again. So then you end up having to either factor or do quadratic formula again. So hopefully you know your quadratic formula. So here, let's see, add 3x, we got 4x, subtract 1, we got negative 10, so we get negative 5 halves is one answer. Subtract x, subtract negative 5 is the other. Alright? Easy. Ready for another similar one? Where'd it go? There it is.
We can't see.
It's similar, I promise. What do you think we should do? Adam?
I don't know.
I don't know. What do you think we should do, Fernando? Do we have any like terms?
No.
Nope. That would be a good first step if there were any.
Do you put a 3x in the first parentheses?
Yeah.
Oh, close. So you're going to say we should factor. Is that what you're going to say? Galen? Factor it. Do you see it? Whenever that is the square of that, meaning if you take that times itself, you get that going. So then it's just regular factoring. This one's going to be x to the 1/3, and this one's going to be x to the 1/3. Because then what's x to the 1/3 times x to the 1/3? 2/3. And then you'll have this times some number plus this times some number, so you'll have a 1/3. And then the back you'll have. Alright? It's good practice factoring. So now you can just fill in the rest.
Yeah.
Alright. It's 3 and 1 for sure. There's no other possibilities there. 4 is either 2 and 2 or 1 and 4.
I'll go 2, 2.
2 and 2? 2 would be 6 and 2. I think I can make a 4 out of a 6 and a 2. 2 and 2. So I need positive 4. So I need positive 6 minus 2, right? 3 times 2 is there's my positive 6. There's my minus 2. There we go. We factored it.
Oh, I forgot to do
So
something.
now you set them in both.
Now
to
you
0.
set each factor equal to 0. And you solve for x. Is that done?
What?
What I did?
No.
How did I get 2/3?
Oh, you divide
I
by
added 2 and then
Oh.
divided by 3.
Duh.
Sorry.
I'm just confused right
How you guys are at the level where I can just mental math. Remember our mental math challenges? Come on.
Was that question, the last question really hard?
On this?
Uh-huh.
You're just not very good. I know how easy this group was.
Who is in that group?
It was all girls, actually. 4 little freshman girls. They worked well together. What do we have to do? What's the last thing? Nope. Third root? That is third root.
Cube it.
Do third power. That's the op. Because if I do both of these to the third power, then I'll just have x. Right? The opposite of third root is third power. 2/3 of the third power, what is that? 8/27. Nice answer there. And -8. Anything that's throwing you off here? Feeling it? Pretty straightforward, right? Last one I'm going to show you. Here we go. Let's go.
Are all of them more questions like this?
Like what?
Is that the question?
Quadratic like?
Yeah.
Yeah.
Is this it?
That's it. I'll give you a minute on this one. You can do it when you're
Alright, so then need to, hold up, I need to like flip the whole one.
Then you just do
Everything.
So you just
I can't.
take the square root of both sides and get this, right?
No.
One of these days I'm going to teach a whole class of stuff like that. Be like, yep, there you go. No, don't do that. That's a joke. It's mathematically correct, but it doesn't help. You can't use x in the solving for x. Okay. So we got x squared minus 2x plus 5 equals 0. I brought them over there. If you put the x squared on the other side, all your signs will just be opposite. But you should get the same thing. Because you go negative b, so if that's already negative, it's positive, right? No x's in the quadratic formula, all numbers. 2 plus or minus the square root of b squared minus 4 times a, which is just 1, because there's 1 there. C, which is positive 5, over 2 times a, so just 2. 4 times 5 is 20. 4 minus 20 is, huh? Negative 16.
Oh, no.
No, this is 2a.
Oh.
Over 2. The square root of negative 16 is
4i.
4i. Remember, any negative square under a square root, just put it, do it like you normally would if it was positive, and put an I at the end. That's it.
What if it's not that? Like, what if it's can't be square root?
So if it's like the square root of negative 80,
Yeah.
you could do 2 times 40, 2 times 20, 2 times 10, 2 times 5. Bring out a 2, bring out another 2, 5 left inside, so you'd have 4 root 5, I. So it's the exact same, just put an I at the end. Because a negative, remember, I squared is negative 1, remember that? So really you just have an I squared under there, and the square root of I squared is I. I believe we'll do more imaginary stuff later. So that's 4i over 2. And then the last thing, whenever you have imaginaries, to write a complex number, it's always a plus or minus bi. Remember that? There's always a real part and an imaginary part. So you want to divide them both by 2. Even if it doesn't work out nice, even if it's fractions, you still divide those both by 2. This one would be 2 divided by 2 is 1 plus or minus 2i. Are your 2 answers. There's 2 answers there, right?
Oh yeah, we're good there.
So yeah, if you came down and your final answer was like this, 3 plus or minus 4i over 5, you wouldn't leave it like that, even though it doesn't divide nicely. You would really just write 3/5 plus or minus 4/5 I. Always write imaginary answers in that form. Did you learn that complex roots always occur in conjugate pairs?
Sure.
I don't know that you've known that.
I've never heard of it.
So then when you do synthetic division,
I hate synthetic division.
for you folks at home, I'll film the worksheet here in a second.
Oh, that card's still there?
I put review stuff on the back because we need to retake that quiz, right?
Yeah.
We should do that one of these days. Tomorrow?
No.
Friday?
No.
Monday next week.
That'll be good. That's all I gotta say.
There's the front. 1, 2, 3, 4. Pause it. Write them down. There's number 5 and 6. Pause it. Write it down. 'Cause I'm gonna need to pause it for that one.
I'll talk about some more.